Hello students, how are you? I hope everyone is good. Okay, student, this is our demo class. Okay, now I'm taking a demo class about some topics. Okay, so first of all, we have discussed last units, that was kinematics. Okay, last unit was our last unit was kinematics. In kinematics, we had studied about number of things, that was displacement, distance, okay, velocity, average velocity, okay, and the speed, acceleration, everything we have studied, okay. But you can think in your mind one thing, that is, if any object is in motion, if any object is in motion, definitely then you are calculating, if you are calculating velocity and acceleration, then definitely body is in motion, okay. So if any body is in motion, then can you tell me some kind, then you tell me body experiences are force, okay. Obviously the body experiences force, then this will be in motion, okay. So tell me, the velocities depends on displacement or not. The question is, velocities depends on velocity, velocity, formula of velocity. I'm asking, velocity is depends on velocity. What is the formula of velocity? Velocity is equals to change in displacement, change in displacement upon time. Tell me, velocities depends on change in displacement or not? Question is this. Or you can say acceleration is equals to change in velocity upon time. Okay. You tell me, velocities depends on change in displacement or acceleration depends on velocity. Okay. The question is that display velocities does not depends on displacement. You are listening this wonder, how it is possible, sir? Okay, so I'm telling you, the quantity force, if force is applied on the body, then velocity will change. If suppose I'm applying force on a body, if force is not applying, okay, if force is not applying, then velocity will not change, acceleration will not change, displacement will not change, distance will not change. So which quantity is depends? Force, okay. Keep in mind, okay, force is our quantity that change velocity, acceleration, displacement, anything, okay. So force is very important quantity. We can say, if force is changing, then what will change? Acceleration will change, acceleration will come, then velocity will come, then change in displacement. Sir, velocity is coming, so you may speed also coming, okay. Speed, change in displacement, or distance, you can say distance will come, okay. If force is changing, so what is the dependent factor? Dependent factor is force. Your answer will be, sir, force, okay. So depending factor is force is changing, then everything is changing. Velocity does not depends on displacement, not in time. So in Newton's law of motion, we will study about the force in detail, okay. So first our topic is frame of reference, because all these quantities depends on frame of reference, okay. If frame of reference we are choosing wrong, then the quantity will be different, okay. Means frame of reference will be different, then quantities, definitions, quantities, distance, measurement will be different. So first we will choose. Earlier I already told you about the frame of reference, but we will detail in here, okay. Now, so our topic is frame of reference. frame of reference, frame of reference. Okay, frame of reference. So definition, we are going first definition. That is, what is the definition frame of reference? Simply definition we are going. It is a coordinate system. Basically, it is a coordinate system. Okay, coordinate system. It is like a displacement. Okay, so it is a coordinate system. It might be in polar coordinate. It might be in a Cartesian coordinate. Okay, so different coordinate system may be there. Okay, so keep in mind we will study about frame of reference. Frame of reference may be Cartesian, maybe polar. Okay, so it is a coordinate system. Coordinate system. I will writing here what it is, polar or xy, or you can say r or theta. Okay, where we have where observation, where observer, you can say observer, where observer is present and he or she makes necessary observation. Okay, so we know about this. There are two kind of frame of reference. Okay, so basically we are going to the next type of frame of reference. Okay, so type of frame of reference, types of frame of reference. Okay, type of frame of reference. So there are two kind of frame of reference. There are two kinds of frame of reference. First one is inertial frame. First one is inertial frame of reference, and second one is first one inertial frame, inertial frame of reference, and second one is non-inertial frame of reference. Okay, so what is the definition between inertial and non-inertial frame of reference? So we are going to tell you definition of frame of reference first of all. So first of all, we will decide. First one is inertial frame of reference. So inertial frame of reference, what is the initial frame of reference? You can write here what is inertial frame of reference. The frame which are at rest. Okay, if any body is in rest, we can consider as a frame inertial frame. Okay, or moving with constant velocity, or moving with constant velocity. So the acceleration of this kind of frame of reference will be 0. Okay, so frame of reference, any frame of reference which has acceleration is equals to 0, then we can say this frame will be inertial frame. You tell me, our Earth is inertial frame or non-inertial frame. Okay. So first you think in your mind, Earth is rotating. Yes, yes. So many of the cases we are taking in the inertial frame, but if anyone is asking and given two options, tell me inertial and non-inertial. Okay, so you will choose only inertial frame. Okay, because Earth is also rotating somewhere. Okay, so you tell me next definition. Next definition will be just opposite to the inertial frame. So the definition will be non-inertial frame will be what? Frame frame which are moving moving with moving with variable velocity variable velocity variable velocity are called non-inertial frame. Okay, are called non-inertial frame. Okay, it means acceleration not be equals to zero. Okay, any kind of frame of reference which has some kinds of acceleration, then you decide this will be a non-inertial frame. So in this universe, everybody is moving, so they are all non-inertial frame. Okay, first you decide nobody is in inertial frame, nobody is in the universe is inertial frame, every is non-inertial frame. So we are going to write a note point in the next slide. Okay, so that is note. You can write down note. Okay, in this universe, in this universe, in this universe, in this universe, nobody are inertial frame. Inertial frame. Okay, all are non-inertial. All are obviously, if not inertial, they will be non-inertial. Okay, all are non-inertial. They all are non-inertial frame. Okay, so in this universe, all the body are non-inertial. Okay, so this is the basic definition about inertial frame and non-inertial frame. And again, I told you, Newton's law is valid only for what? This is most important because we are going to this chapter, laws of motion. So laws of motion is valid only for the inertial frame. Okay, yeah, we can also write here all Newton's law of motion. Newton's law of motion. Newton's law of motion are valid for inertial frame. Okay, and in our calculation for making calculation easy, we can take our earth is a inertial. Okay, क्या मान लेंगे? We will consider inertial, sorry, our earth is inertial frame. Okay, inertial frame. Okay, or you can say ground ground frame is inertial. Why you can say inertial? Because with respect to gravity, the acceleration is very small. Approximately इसको बोलते हैं approximately. Okay, the ground frame is inertial frame because it has very low acceleration compared to velocity, compared to Earth's acceleration gravity. Okay, so now next topic is our next topic is what is force. Because you know everything is depends on force, like acceleration, like velocity, okay, displacement, everything is depends on force. So first we will discuss about force. Force definition is also coming from the Newton's law of motion. So first we will discuss about the force. What is force? Okay, the question is what is force? Okay, what is force? What is force? Okay, so you can tell me what is force. In in junior classes we have studied simple definition. You know what? Every push or pull, or tries to pull, tries to push. Okay, I'm writing here. Every, it is a, it is a, okay, push or pull which changes, which changes, changes the position, which changes position, or we can write configuration. Okay, configuration. Configuration means everything: position, shape, size, anything. Okay, which is a push or pull which can changes, which can change or tries to change, or you can write tries to change, tries to change. Okay, tries to change the state of body, the state of body. So this is known as what? Force. Okay, this is called basically force. Force, what is force? Force is a factor which can apply on the body, and body can change some configuration or tries to change. If suppose I'm pulling the ball, okay, or pushing the ball, so we are applying the force on the ball, but ball is not moving anywhere. Okay, so we are applying force or not? We are applying force. Okay, because we are trying to change its configuration. But if suppose I am giving more and more force, then ball is break. Okay, so its position will be changed, its configuration will be changed. So this is known as force. Force is giving real effect. Force is giving real effect. Okay, so now I'm coming on the next types of force. Okay, types of force we will basically in base junior classes we will discuss. Now I'm going to in detail. Okay, detail in every part. Okay, types of force, types of force. So there are four types of force that is known as also fundamental force. Okay, we have already studied in first chapter fundamental force. Okay, fundamental force. So these are the fundamental force. First one, this is called gravitational force. Gravitational force. Okay. Second one is electromagnetic force. Electromagnetic force. Third one, weak nuclear force. weak nuclear force, and fourth one is strong nuclear force. Okay. So weak nuclear force and strong nuclear force exist only in nucleus. Okay. They are applicable in the nucleus. Okay. So you may write here, these kinds of force is in nucleus. These forces act inside the nucleus. Okay. So remaining two are the shows the effect in the nature. Many times we have seen the number of forces. Okay. So there are only two kinds of force. It might be gravitational force or it might be electromagnetic force. So what is gravitational force? Gravitational force will be like this. That is like mg, okay, or g m1 m2 upon r square. Okay. And electromagnetic force, that is also normal reaction. So this is a electromagnetic force. Yes. Tension, friction, kinetic friction or static friction. Kinetic friction or static friction. Everyone. Okay. Spring force. Okay. Spring force, Coulomb force, that is K, Q1, Q2 by R square. This is also electromagnetic force. Okay. So normal tension, normal tension, friction force, spring force, kinetic friction force. Okay, all are viscous force, etc. Okay, all are electromagnetic force. So number of forces fall on this category. Okay, number of forces means maximum force in the universe falls on electromagnetic force. Okay, this is we are going very we will go in detailed. Okay, so weak nuclear force, strong nuclear force, this is act in the nucleus only, and gravitational force we will study in gravity chapter gravitation. Okay, and electromagnetic force and electromagnetism, complete part of class 12. Okay, we will study, and normal reaction, tension, friction. Okay, we will study here. Okay, now classification of force. How can you decide type of force? Means classification of force. So we are going to hear next topic is classification of force. Okay, classification of force. Forces, classifications of forces. Okay, so there are two kinds of force according to this classification. First one is from here. First is field force. Okay, field force. Second one is contact force. This is also called non-contact. Okay, some types of force which is may applied on the body, that is if we are going to directly contact, then this is called contact force. If is I'm going to field, like magnetic force, electric force, gravitational force. Okay, so these are the field force. Okay, so there are two types: field force and contact force. Field force and contact force. Okay, and we can say what is field force. Field force we can write here like mg, okay, g m1 m2 upon r square. This is also field force. Okay, gravitational force this is called gravitational force. This is electrostatic force, k q1 q2 by r square. Okay, and q b cross b, this is also field force. Okay, non-contact force like mgg m1 m2 r square k q1. This is the example. Okay, this is basically example. Okay, now here example: normal reaction, tension, friction, static friction, kinetic friction, viscous drag, viscous drag. Okay, so these are basically contact force. Okay, this is called contact force. We can also classify in two part, that is real force and pseudo force. Okay, so this is, we can also going to classify real, real and pseudo. Okay, real and pseudo force. Real, real force or pseudo force. Okay, what is real force? Real force means the effect of the force is actually real. Okay, suppose if any object, you are sitting in a bus. Okay, and bus is moving. Okay, bus is moving. If you are taking itself in rest, okay, then you will say the strips of the road coming towards you. Okay, by some acceleration, by some acceleration. So what you will decide? You are decided, you are in rest. Okay, and are road strips are moving towards you. Okay, so what is the actual things? The bus is going, bus is accelerated, so bus is in acceleration, bus having some force, so that kind of force is real force. And what is pseudo force? If you are taking in rest or bus is taking itself in rest, and the strips of the road are coming towards the bus, so that strips are feel like in acceleration, so some having some force, so this kind of force feeling by the steps is called pseudo force. Okay, so what is real force? Real force is like real force. Example I'm giving here. What is example? Like mg, okay, g m1 m2 upon r square, friction, okay, kinetic friction, static friction, normal reaction, tension, okay, k q1 q2 upon r square. This is also a real force. Okay, and what is pseudo force? M into a naught. Okay, m into a naught mb square by r, or you can say mr omega square. Okay, and one you will say 2mb. We will we will study in detail. Okay, so don't worry, we will study in detail. Okay, so don't take any type of tension. Okay, this is the classification. We are going to tell you about the force because we are studying at advanced level. So that is a kind of force because it is very important to us. Okay. If you are not understanding particular topic like force, then we cannot do anything further. Okay. So again, I am classified in one thing. Classification is going on. Okay. So next also classified force. Okay. That will be like this. Again, I am classified in two parts, that is conservative and non-conservative. Okay. Conservative force. What is the conservative force? I'm going again in classification. Classification. Conservative force. Conservative and non-conservative. Okay. Non-conservative. Okay. Conservative force and non-conservative force. Okay. So first we are going to the definition. Definition. What is the definition of conservative force? Which do not dissipate any kinds of energy in mechanical process. Okay. Which do not dissipate mechanical energy of the system. Okay. So this is called conservative force. इनको हम लोग क्या बोलते हैं? We will call conservative force. We will call conservative. Okay. And opposite here we can write here which dissipate mechanical energy of the system. Okay. So this is called non-conservative. Okay. So this force are called non-conservative force, and that force is known as conservative. Okay. So the example like G M1 M2 upon R square, conservative. Okay. K Q1 Q2 upon R square. Okay. Spring force is also conservative force. You know, spring force is also conservative. Okay. And here we will say friction force, friction, kinetic friction or static friction is also a force. Viscous drag, viscous drag, viscous drag or air drag. Okay. Air drag, viscous drag or air drag. These kinds of force. Okay. Normal reaction. Okay. Tension. These are the conservative force. Okay. So basically, this is also classic. You can also classify force types of force, conservative and non-conservative. Okay. And one thing we will study here again, same the classification, that is internal force and external force. Okay. Again, I am classified. You can also do the same thing. External force and internal force. What is internal force and what is external force? So external force and external force and internal force. How can you decide internal or external? Okay, first of all, we will decide external if particle system, if any system, if two particle is the system of any type of system. Okay, so you can decide. Firstly, you can decide external or internal. This is a part of system or this is not a part of system. Okay, because this is based on the our selection. Okay, we can say this system is separate, so the particle will go out of the system. Okay, so we are deciding. This is based basically based on selection of system. Okay, I'm giving example, don't worry. I'm giving example. Suppose you know a body A, okay, a body A, and this is body B. Okay, this is body A and this is body B. Okay, this body, according to Newton's third law, you have already studied in junior classes. So if your body applying on force on body B, so this is force and this also experiences force and this is also applying force. Okay, if the system boundary is, I'm saying, how can you decide these two kinds of force, external or internal? So this is decided by the external boundary. Okay, if we are choosing boundary like this, okay, yeah, this is the boundary. Okay, this is the boundary of system. Okay, this is boundary of system boundary, system boundary. So what is this? What they are, F12 and F21 means FAB and FBA. Both are means both are external force or internal force. Both are internal force because the boundary system they contain in the boundary system. Okay, they contain within the boundary system. Okay, if so, FAB and these two are in cases these two are internal force. This is internal force. Okay, if we are going to decide a boundary like this, okay, uh, if we are going to decide boundary like this, okay, then they are called external force. Okay, so if they are containing same boundary, then internal force. If they are containing different boundary, they are called external force. Okay, so this is our topic for demo class. Thank you. Okay.